Hey third graders, it's Miss Dignam here again. Today we're going to review ourselves on the relationship between repeated addition and multiplication. And if you notice that word relationships underlined, you're thinking, what does relationship mean? And relationship is really the connection. What is the connection between repeated addition and multiplication? How are they connected? So let's start with addition. We know that we can add a quantity or number together to find the total or the sum. So here we have apples, and we can add each group of apples to find our total. We can also find a total by multiplying. Multiplication is an efficient way to solve repeated addition. Efficient means how can I get the answer quickly and have it make sure that it's correct? Here I'm seeing 3 groups of apples, but say there were 32 groups of apples. If I were to use repeated addition and add 2 and do it 32 times, there's a good chance that I could make a mistake counting, or I could lose track of my counting and have to start over. Or I could count them, but maybe I forgot a number while I was counting. In that case, we might want to use multiplication because multiplication, again, is a more efficient way to solve repeated addition. We can add equal groups efficiently by multiplying because being efficient means being quick and correct with our math. And that's exactly what we want to be when we're mathematicians. So let's see how they're connected. So I'm looking at these 3 groups. I'm going to first start by making an addition number sentence. First, I'm going to start with this group. How many apples are here? There are 2, so my first number should be 2 plus. Then I have to add another group of 2 because I'm seeing a second group in this model, so I'm putting a 2 there. And then my third group has 2 as well, so I'm writing plus 2. 2 plus 2 plus 2 matches this model because I'm adding the number 2 and I'm doing it 3 times. Look, here's one group of the 2, here's the second, and here's the third. Okay, so we know how that part matches. So now let's look at how can we solve this also by using multiplication. Because remember, we can multiply to be more efficient and we'll still get the same correct total because we multiply our factors to get our total. Just like we multiply our digits here to get our total when we add. So let's start. We know in multiplication we always start with our groups. So I'm thinking, how many groups do I see? Group 1, group 2, group 3. There are 3 groups. My first factor is 3. My second factor is my each. So how many are there in each? Well, there's 2 in this group, and there's 2 in this group, and there's 2 in this group. So how many are in each? There's 2 in each. 3 times 2 gets me to 6. And let's prove why. 1, 2, 3, 4, 5, 6. There are 6 total apples. So if 3 times 2 equals 6, then we also know that 2 plus 2 plus 2 also equals 6. All right, let's check out the next one. Here we have an addition number sentence. It's a repeated one because I'm seeing 6 plus 6 plus 6. And I'm thinking, how can I represent this with a visual? So I'm going to start with drawing equal groups. And I'm looking at my first 6 and I'm saying, oh, there must be a group with 6 inside, so I'm going to make a group. And my groups are just going to be circles. And I would put 6 inside. 1, 2, 3, 4, 5, 6. I also have I'm adding another group of 6, so I make a group and I put 6 inside. 1, 2, 3, 4, 5, 6. Then I also have a third group with 6 inside as well. 1, 2, 3, 4, 5, 6. If you take a minute, you're thinking, oh my goodness, I am drawing equal groups. And you're thinking equal groups, well, I could also, instead of adding over and over, I could just multiply them and get the same total. Because remember, we want to be quick and correct. Good mathematicians use efficient strategies. So let's multiply. Let's write the number sentence that matches. Well, we know that when we multiply, we always start with our groups. So how many groups do I see? 1, 2, 3. Okay, I see 3 groups. My second factor is how many in each? 1, 2, 3, 4, 5, 6. That means this group has 1, 2, 3, 4, 5, 6. And this group, 1, 2, 3, 4, 5, 6. Each group has 6. There are 6 in each. So if you're looking, 3 times 6 is the same as 6 plus 6 plus 6. And I can find the total by counting them all together. Well, we know that there's 6 in this group, so I'm going to count up. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if 6 plus 6 plus 6 equals 18, 3 times 6 also equals 18. Now let's also prove it. So let's look. We have 3 plus 3 plus 3 plus 3 equals 12. And this is saying that another way to get the same total as 12, you could also do 4 times 3. So let's prove how that's true. On this side of the page, I'm going to draw an equal groups model. So I have a group of 3, 1, 2, 3, and another group of 3, another group of 3, and another group of 3. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That matches. 3 plus 3 plus 3 plus 3 does equal 12, and we show that by drawing equal groups. Now let's look over here. Instead of drawing equal groups, let's use a different strategy. Let's use an array. Actually, I take that back. Let's do equal groups for this as well and see if it looks the same. Well, remember, when we look at our first factor in multiplication, we know that it's our groups. So there should be 4 groups. So let's draw them. 1, 2, 3, 4. Our second factor is each. So each group has to have 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, and 1, 2, 3. If you're looking, they are completely identical. Let's just prove it by tracking our counting to see if we get to 12. So let's count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We just showed that we can solve repeated addition by also rewriting as a multiplication number sentence, because multiplication and repeated addition are the same thing. It's just another way or strategy to get to the total of something. We got to 12 by adding our equal groups together or multiplying 4 groups of 3. It's the same thing. They are equal. All right, let's prove it once more. So let's do the same thing, except this time let's use different strategies. So let's do an equal groups on the addition side. So I have a group of 2, 1, 2, another group, and a 4th group. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. 2 plus 2 plus 2 plus 2 equals 8. And we showed that to be true by drawing an equal groups model. Now, let's draw an array over here. So I know that my first factor is always my groups. So I should be drawing 4 groups. So 1, 2, 3, 4. My second one is my each. So in group 1, there should be 2. And in group 2, there are 2 more. In group 3, there's 2 more. And in group 4, there's 2 more. Notice how I'm keeping my rows and columns nice and organized. They go straight down. Now let's count them together to find out if the total matches. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it sure does match. 2 plus 2 plus 2 plus 2 gets you the same answer as multiplying 4 times 2. 4 times 2 means 4 groups of 2. And if you notice, over here, I'm seeing all of these 2's because when we rewrite it as repeated addition, we're just adding our each. And you're going to say, well, how many times do I do it? Look at your groups. There are 4. So I should see 4 number 2's over here. 1, 2, 3, 4. 4 times 2 can be written as 2 plus 2 plus 2 plus 2. All right, friends, now that we've reviewed that together, you can start our form below and think about how multiplication and repeated addition are connected. See you later.